Hi, welcome to the Grafana Alloy for Beginner series. My name is Mischa Thompson, and I'm a senior software engineer at Grafana. By now, you should have completed all 4 hands-on exercises to test your knowledge. Let's go over the solutions to these exercises. Just for your reference, the solutions to all the hands-on exercises are included as branches of the series repo as well. For mission 1, the hidden key, just as a reminder, there's a key that's being hidden somewhere, and our task was to find it. So in the instructions, it says to access the Alloy UI and look for the hidden key in one of the service discovery targets. So let's first pull up the Grafana Alloy UI. And we only really have one service discovery component that we configured, this discovery.htp.service discovery component. So we can now view this. And if we can look through all of the different targets that are being exposed, there's one kind of thing that sticks out to us, this __ meta decryption key. And we can see the value is ghost protocol $, a password that hopefully you don't use in production. So now to decode it, you can go to the repo. I've already copy pasted the instructions, but the instructions cover what you need to do. You're just going to run this command with that password that we just found, and you should get a fun fact about Grafana Labs. All right, for mission 2, just as a reminder, we were tasked with dropping a very high cardinality metric after extracting some useful data from its labels. We're provided with a regular expression that we're going to use in a second. Let's hop over to the code. So the first thing we're going to do is jump over to section 4, and we're going to modify and add a new Prometheus.relabel component. Then we're going to hook up our Prometheus.scrape to now forward metrics directly to this new Prometheus.relabel component. So we're adding something into the chain. Previously, it went Prometheus.scrape and then directly to a Prometheus.write.queue component. And now, so we're adding something in the middle there. So going over to our Prometheus.relabel component, we're going to be adding 2 relabeling rules. The first one is sort of the core one where we're going to extract data from the labels that already exist. So we're first going to configure the action that we're going to be performing, which in this case is to replace. So you can replace a non-existent label. That label in this case is the target label. So this is the label that we'd like to ultimately modify. And that's this cloud provider label. Source labels configures where we're going to be potentially pulling information from, if we are. And the regular expression lets us basically match things against those source labels. In our case, source label is just a single value, but theoretically you could have multiple and concatenate outputs. So using that regular expression, we're going to use a replacement of $1, which is just a shorthand to say replace the value, the first found value from this regular expression. So it's going to be one of AWS, GCP, or Azure. Then our second block is going to be doing the dropping. So part of the whole problem was that we have this really high cardinality metric that ultimately is going to increase Mimir's memory usage over time. So we'd like to make sure that we only extract what we need and drop the rest. So that second rule is going to use an action of label drop, which as the name describes is going to drop a label, and the regular expression instance ID. So in this case, no dynamic matching, but just drop instance ID directly. And then, of course, don't forget to update your forward to for the Prometheus.relabel to now complete that pipeline and send it to the Prometheus.write.queue component. To validate that everything is working correctly, let's go to the dashboards link. It should take us to our local Grafana, go to our mission 2 dashboard. And so we should be able to see the total in-memory series from Mimir, the database cardinality. In my case, this is flatlined because I've been running it with the solution the whole time, but in your case, you may see sort of like a staggering graph that then should taper off once you've added this new code. Secondarily, to verify that you've actually added the label correctly, we can navigate to the Explore page, copy the provided query, select the right data source, and you should be able to see non-zero values. So that means that we're now getting this many metrics with this particular label. So as long as you see something non-zero here, that means you've done it right. For mission 3, remember that our task was to align all of the attributes for the spans that we're sending. So until now, teams have been sending these conflicting keys like service tier, and we're now trying to standardize on service.tier. So our objective is to use the hotelcall.processor.attributes component to set that and then drop the other values. So let's hop over to the code and do that now. So as was mentioned, we're going to be jumping over to section 5 in the instructions. We're going to be adding primarily this hotelcall.processor.attributes component. And so our first step is going to be, we're going to take an action, which is to insert. So we're going to take from an old attribute, one of the non-standardized ones, and we're going to move it over. We're going to insert a new attribute. So the key, that's the value that we're trying to modify. So that's the attribute that we'd like to add, or it's specifically the key of the attribute we'd like to add. So in our case, we're saying from attribute equals service tier. So from the old value of service tier, copy that value over to a new attribute named service.tier. Second action here is to delete anytime we find this key service tier, that non-standard one. We're going to repeat the same two actions for the tier key. So that's another one, that's the old non-standard one, and we'd like to first insert into the service.tier attribute key, and then take the value from the old attribute of tier. So in this case, if there was a span that had the service tier, so the old one, no dot, this action will not do anything, and neither will this one to delete the tier because they didn't exist in the first place. Then we're going to configure the output to hook up to the hotel call processor.batch so that we can get all the nice network benefits from that. And then, of course, don't forget to update your hotel call receiver.otlp to forward to this hotel call processor attributes component. So to verify that things are working correctly, we'll navigate to the dashboards. And we'll go to this Mission 3 dashboard. And you should be able to see these values climb. And you should be able to see basically that we have this correctly tiered. And where these metrics come from, they come from span metrics. So basically, Tempo is configured to listen for that service.tier and then generate some metrics from it. So previously, nothing was being generated. As soon as you start sending spans with the correct attribute, then you should be able to see something here. If you'd like to double check that you're dropping things correctly, you can navigate to the Tempo data source and explore. Use the search functionality, and if you go to tags and you look for service.tier, you can see that we have two different values, medium and high. So we'll query for one of those. And we'll pick a particular trace. If we look at the span attributes here, we can see we have the service.tier of high, but we can see there's no service tier or tier. So that means that we've successfully extracted the old value and dropped, in this case, whatever that old attribute key was, and we've gone only with the standardized one. All right, for mission 4, just as a reminder, our objective here is to redact any tokens that are found in the logs coming from the mythical microservices. So a hypothetical opposing state actor has exploited a zero-day vulnerability and gotten our services to start logging their Grafana tokens. And we want to use Alloy as sort of a stopgap to redact those tokens, make sure that they don't get logged remotely, and then until our team can come up with a better long-term fix. So the instructions say to take a look at the Loki components and see if there's anything that sticks out to us. So if we navigate over to the list of Loki components that we can use, there's quite a few of them. They can do all kinds of stuff, places that all these Loki.source components can pull logs from different places. And so if we ignore those for the moment, and we already know what Loki.write is, we know it's kind of good. This Loki.echo, that doesn't sound quite right. Loki.enrich is adding more things to it. Loki.process we've used before. Loki.relabel is about relabeling. There's a couple of others. But this Loki.secret filter looks like it could be interesting. So if we navigate to the documentation here, we can see that this is an experimental component as of the recording of this video, but the demo environment does set the experimental stability level flag, so we should be good there. And what it does is it receives log entries and redacts detected secrets from the log lines. So it sounds like exactly what we're looking for. So it can use a custom configuration file based on the git leaks configuration file structure, but I can tell you that for the demo, you don't have to set this up yourself. The default will work entirely. So should be pretty straightforward to configure because we're using all defaults. Now it does say which section would you add this component to. So if we think about for a moment the previous sections that we've looked at, we first set up logging for Alloy itself, but it's not Alloy that's logging these tokens, it's the mythical microservices. So I do happen to know offhand that the section number for that is section 6. So let's hop over to the code for section 6. So in section 6, we had set up that loki.source.api component and set it to forward to this loki.process, where we did some kind of more complicated processing. Now that we know our loki.secret filter is what we want to use to redact those tokens, it's sort of just like injecting that prometheus.relabel component that we did not too long ago in a previous mission. So we're just going to rewire the loki.source.api to, instead of forwarding logs directly to the loki.process, it will now forward to a newly created loki.secret-filter component, and that loki.secret-filter component will forward the now redacted logs to the loki.process component. And so don't forget to reload the configuration once you've done this. And so to verify that things are working correctly, you can navigate to the dashboards and the mission 4 dashboard specifically, and you should see something that looks sort of like this. So 2 panels. The top panel is showing the count of logs, so the number of log lines at a particular point in time that had a Grafana Cloud token in it. And so once you've reloaded the config and it's being applied and Alloy is hopefully redacting things, you should see a drop off in terms of those metrics. As well, we have this logs with token panel that has basically the actual raw log lines. And so to verify that things are coming in and it's not just, that Alloy isn't sending anything at all, there should be this token equals redacted secret Grafana Cloud API token. So if you see both of these things, or this panel is entirely empty, if you've let it run long enough, then that means you're good to go and you're redacting all of your tokens.
And that's a wrap on our Grafana Alloy for Beginners series. Thanks so much for watching, and we'll catch you next time.